Hey guys, welcome back to another ARIA SK Maths video, and in this video I'm going to be explaining the question you see over here. Why can't you differentiate both sides of an equation? So I'll give you an example I was trying to solve the other day, and hopefully you'll see why this might be a valid question. So let's say we're solving the equation x equals cosine of x, okay? Now we can actually draw the graphs of this. So if we have the y-axis and x-axis, we know cosine of x is going to come something like that, and x is going to have to go through the origin like that. So inevitably they're going to cross somewhere over here, and we're just trying to find this x value, like so. So this is actually our solution to the equation. Now this ordinarily is actually a really difficult equation to solve, and it might actually be seen as impossible because the solution is actually transcendental, if that makes sense. So you might be thinking, why can't we just differentiate both sides of the equation? So this is what I did. Differentiate the left side and differentiate the right side, like so. And this is going to leave us with 1 is equal to negative sine of x. And then this is an easy equation to solve because we just have to solve sine of x is equal to minus 1. And this is just going to be when sine of x is either 270 degrees or 3 over 2 pi radians, like so. So yeah, we have a solution, well done. But you might notice if we plug this in, so obviously this is actually out of the bounds, but if I just were to extend this graph coming down like so, let's just try and bring that down like so, and 3 over 2 pi radians, so that's going to be, let's just think about this, so yeah, it's going to be somewhere around this point, because at 3 over 2 pi radians, cosine of that is actually 0, I believe. So let me just think about that. So this is going to be pi over 2, this is just pi, so that's 3 over 2, yeah. So cosine of 3 over 2 pi radians is 0, and when x is 3 over 2 pi, this line x equals y, well that's just going to be somewhere up here. This is just going to be 3 over 2 pi, 3 over 2. So obviously there's some kind of discrepancy here because these are not equal to each other. So what's going on? Well, I'm going to be showing you guys why you can't differentiate both sides of an equation, and I'm going to try and explain in two kind of ways, so hopefully you can understand them. But yeah, so let's just start a new page. If you didn't see that, this was the other one. But yeah, so what we need to realize is that there's different kinds of functions. So we have a regular function, let's just call this f of x, and let's just say this returns x plus 9. Let's just have this. So you can see this function takes in a value, takes in x, and returns x plus 9, just like that. So we pass in numbers, and we want to get numbers back, just like that. You can call that real to real, or it could just be number to number, because you can also pass in complex. But the derivative function isn't actually like that. If we take dy, or just d over dx of some number, or it's not even a number, this is the main part. You need to realize that when you pass in something to the derivative function, you're not really passing in a number, you're actually just passing in an entire function like this. So dy by dx of f of x, and that is going to return another function g of x. So I hope you can see the difference, because when you're passing in numbers to ordinary functions like this, you put in a singular number, or if it's multi-numbered, multivariable, then you're going to put in multiple numbers. But the idea is that you're putting in numbers and getting out other numbers, whereas the derivative function is a function which takes in an entire other function and returns a different function. You can see examples of this if you say, let's just say, just like the one above, if we take dy by dx of sine x, that returns cosine x. So we are taking in entire functions like so. So these kind of functions actually have different names. So they're not just regular functions. They're actually called operators. Let's just see if I can fit this all into one line. Yep, that'll have to do. Yeah, so these are actually called operators. So you can see they don't work like a regular function, and you can't really plot this. Like, you can't really plot a derivative function. Let's say this was the function of f of x. It just, some kind of weird function does this. So this is taking in x values and returning the corresponding y values, just like that. Now, if you have never seen a derivative function, because that's not how they work. There is no derivative function dx. Derivative functions can actually be seen as, you can sort of see them as mapping one function onto another. So if we carry on using the sine example, if we just say we take in the sine graph, like so, the derivative function is actually just going to map this to the cosine function. So it's really just transforming functions rather than actually doing anything with numbers themselves. So now this should make sense why we can't take derivative of an equation, because in an equation, if the derivative function transforms functions, then let's just carry on over here. Let's draw our graph. So if we had the function y equals x and cosine of x, like we said before. So now you can see, if we think about it like this is the derivative function on both sides is going to transform these into completely different functions. So when we take derivative of y equals x, that's just going to give us x equals 1, like so. And when we take derivative of cosine x, we're going to get negative sine x. Let's see if I can remember how to draw that. So I believe it's just going to be reflected in the x-axis, I'm pretty sure. Sorry, no, it's going to be reflected in the y-axis. So let's just say if we had of 90... Actually, yeah, it's going to be reflected in the x-axis. Okay, so let's just bring this down like so and like that. I think that's what it's going to look like. Let me just think about this for a second. So if we have y equals negative sine of x, and if this was our x equals 180 degrees, that was going to be 0, so that's that point. And if it was 270, that would be 1. So yeah, this is what it looks like. So this is actually not to scale, but this is 270 degrees. So this is our supposed solution, which we got over here, 3/2 radians. And you can see this is why you can't use it to solve for this original x here. This is the x which we want, but we instead got this x. Sorry, this is the name of the function. And this x, this is just x equals 3/2 pi. So this is the wrong x. We want this x. And this, hopefully this makes sense. You can't really differentiate both sides because it's just going to turn the equation into a completely different equation. The reason, now you might have come across the idea that you can differentiate both sides on identity, and that's true. So if we had the identity, we know that sine squared x plus cosine x squared x is equal to 1. So we can actually differentiate both sides of this identity completely fine. If we take both derivative of both sides, we need to remember the chain rule. So we're going to get 2 sine x cosine x and minus 2 cosine sine x, and derivative of 1 is just 0. And you can see this is a true statement because these two are equal, so when we subtract them we do get 0. And the reason for that is because I don't actually know the graph of this, but actually I do, because it's identical to 1. So you can see this is what the graph of sine squared plus cosine squared looks like. And since this is both the same thing, these are equal for all values of x, and therefore the derivative, when you take derivative of both sides, it's going to give out the same answer. So that's actually just going to be 0. So here we go. And that's why you can still take the derivative of both sides of an identity, just not an equation. So that was a bit confusing, and I'll try and make it slightly less confusing with another explanation which I've heard, which basically states that if you're going to take the derivative of both sides of the equation, so let's just go back here. If you're going to take the derivative of both sides of this equation, you're actually going to be now solving for when the derivative of this is equal to the derivative of this. And remember, derivative is just the gradient. So if we represent it like this, you have one function of x is equal to another function of x. When you take the derivative of this function, set it equal to the derivative of this function, you're really just looking for when, let's do this in purple, you're looking for when their gradients, dy by dx, are the same. So that should make it clear why you can't use this to solve for the original x. You're actually just looking to see where the gradients are the same, and that actually explains our earlier occurrence. We actually solved for x is equal to 3 over 2 pi, and if we look down here, you can see from our thing that this is actually true, because at this point dy by dx of y equals minus sine of x, well, that's just going to be equal to 1 when we put in that's just the derivative of this is just 1. Sorry, this is the wrong graph. You're not really solving for this x anymore. You're solving for when the gradients are the same instead. So yeah, hopefully that explains why you can't differentiate both sides of a equation, but you can differentiate both sides of an identity, because an identity, all values of x will give out the same y. So when you apply the derivative function, you're going to transform it to give out the same graph, so therefore you can still use it to solve for x. But you might notice if you're going to try and solve for x and identity, you're just going to end up with a true statement, because this is true for all x. So hopefully that answers the question. I'll try and summarize pretty briefly. You can't differentiate both sides of an equation, because when you differentiate both sides of an equation, you're actually going to be solving for when their gradients are the same rather than when their points are the same. And remember that differentiating a function, the derivative function takes in an entire function and returns another function. So it's not a regular operator in the same sense of like dividing both sides by 2 or squaring both sides. So that's why you can't differentiate both sides of an equation. Thanks for watching, and I'll see you guys in a future tutorial. Bye.